Software installation. For the final project of this Domestika course, you will learn how to make a short animated bumper, a logo animation for a hypothetical customer, in this case Domestika. The peculiarity of this course is that we will only use Unreal Engine 5 from modeling to final rendering. The features of Unreal Engine 5 allow for great artistic control about what we are doing. The final design has been thought out so that you can use and learn all the fundamental modules of Unreal Engine. If you follow all the lessons of the course from start to finish, not only will you be able to exactly replicate the project that I show you, but you will have the basics and the knowledge to work independently and create your own personal project. So let's start with installing the software. To do this, we need to point the browser at unrealengine.com. You will be prompted for a short registration. The data to enter are few, and the procedure is really very fast. At this point, you can click on the download button to actually start the software download. Here you have to choose between two versions of the Epic Launcher, the publishing license and the creator's license. What interests us is the creators, because publishing is mainly involved in the development of video games. We can safely click on the download button to download the Epic Launcher installer, which is nothing more than a software that allows us to manage several Epic game software, including Unreal Engine. The installation for both PC and Mac is standard. As with any other software, the procedure is quite fast. The Epic Launcher at first start looks like this. On the left, you can see several sections, such as Home, Store and Library, which concern, more than anything else, the Epic Games video game store. What interests us is the Unreal Engine section. In turn, it is divided into several tabs. The first, as you can see above, deals with Unreal Engine 4 and contains the latest news and interesting articles on the world of UE. From the Learn tab, on the other hand, you can download different projects already made for study. They are very interesting, and I recommend the content examples, own made by Epic Games, which contains an exemplary scene for almost all Unreal functions. It's very simple, just click on the content and then click Create Project again to install it and have it in your library. The other tab is the Marketplace, which allows you to download pre-made scenes, 3D objects, sounds, plugins, and, why not, it allows you to upload and sell the assets created. In the Library tab, on the other hand, we find the list of versions of the engine that we have installed. Now there is nothing, of course, the projects we are working on, and in the vault all the assets we downloaded from the Marketplace. Twinmotion is a version of Unreal for architecture, which we will not cover in this course and which, therefore, we skip. The new UE5 tab deals with the new Unreal Engine 5. It is, indeed, the only way to install the new system. In early access, click on Download. The software warns us that version 5 is early access and therefore cannot or should not be used in production. We don't care, because our course is fine. Once the installation has started, let's go to Options and take out those things we don't need and that save us space on our hard disk. Engine source, the source codes do not interest us. We remove everything we find in the Target Platform tab. We can install. At this point, just wait for the software to download and install it inside the Epic Launcher. You have now seen how to install Unreal Engine 5. In the next lesson we will see the first start, and we will do a brief overview of its interface. Interface overview, modules. In this lesson I will show you the interface of Unreal Engine 5, so that you can orient yourself naturally in the software. We will also see how to import assets into Unreal Engine, be it 3D models or images. Let's begin. Unreal looks like this the first time we launch it. We are asked to create a first project, to give it a name, and to choose among the various presets available. Let's start by giving it the name. We can choose any name, and why not enter Domestika? On the left side, you can see recent projects. We don't even have one, because we just installed it. All the various presets, that is, if we go to select among the various types, game, film and video, architecture and automotive, etc., we are presented with preset templates, inside which there is part of a scene already made, or some software settings that can help us, like managing a character for a game. Different types of management, i.e. the view from above, the first-person view, or projects optimized for augmented or virtual reality. At the moment, we don't need this help, although we can call them back later and then we'll see how. We choose blank, that is, a clean, new setting, inside which there is practically nothing. Once you have selected our preset, we will be asked the characteristics with which we want to create it. Blueprint or C++ are the first options. Our project is based on blueprints, that is, based on visual programming. Target platform, we leave desktop and not mobile. Quality preset, maximum, we select starter content because we selected it during installation. Contains various objects, modules and basic materials, which in any case are used to start the project. We don't enable ray tracing because we won't be using it in the course. We will use global illumination, but not hardware ray tracing. We are now ready to click on Create. On first start, Unreal Engine 5 looks like this. It is likely that the first time you start Unreal, you will have to wait a long time for it to compile the shaders. This can range from 2 minutes to 5 minutes or even a lot more, based on your computer hardware. There is a possibility that your interface is different, according to your machine and your installation. To be sure, go to Window, Load Layout, UE4 Classic Layout. Let's check. The upper part looks like a normal Windows software file with the possibility of making a new level, to open a new level, to save, to export and the rest. Edit, Window. For the management of the interface we want to show Tools, Build, which we will not see in this course, because luckily we don't need it. And the always present in every software, Help. The top bar to activate different tools. The left part preset with the place actors. The list of actors, because Unreal calls every object on stage actor. Then we have our viewport. On the right, the world outliner, which is nothing more than the list of objects on stage. If we select any object with the left mouse button, we find it highlighted on the right side of the world outliner. Below, the Details tab. Each object has its own Details tab, that is, its characteristics and settings. Below we find the Content Browser. It is essential because the imported objects are contained here, and even those we create are then put into this Content Browser, which, like any Explorer or file manager of any operating system, works on folders. In fact, in our Content Browser, we will find the Starter Content folder. We open it, and we see that inside it there are several subfolders with different elements. They can be geometries, audio, images, materials. Then manage the Content Browser and folder order well. It is at least recommended, because it is easier to find your way around our project. Let's see how to customize the interface. How to make the interface fit our monitor and our needs. As in all modern software, Unreal Engine also works by tab, so we can move, for example, the Content Browser and put it in the Main tab, so we no longer see it on the main screen, but at the top. As in modern browsers, we find the Content Browser. This is true for almost all the other tabs. Of course, we can climb as we please any window. We can reorder the tabs as it suits us. And, in every moment, when we have a little confusion, we can always return to the initial state with Load Layout, putting the default one of Unreal Engine 5, or returning to the classic setting, as Unreal has always accustomed us to. Let's see the default setting of Unreal Engine 5 with the news. The thing that has been added is the ability to hide the various tabs, especially the content browser. We can then choose to attach it to our layout, and therefore make sure that it is always visible. The content browser is very important and is the only one that has additional options, such as choosing the size of the thumbnails. I went to the texture section so that it is better understood. Thumbnail size: tiny, small, medium, large, huge, and so on. Another important thing about the content browser is the possibility to search. To create collections, you can name a collection and match it to any group of objects. So let's do a collection, new collection. Inside, we can insert this image, the geometry, and an audio. In the content browser we will have this new collection. We can rename by pressing the F2 key. Once we click on a collection, we find the object selected before. As for a first mention of the content browser, this may be enough. One of the most important screens, of course, is the viewport. It allows us to navigate within our project and to move within it. Let's see how to navigate within the Unreal interface and the viewport. To shift the view while keeping the camera in the center, just click the right button and move the mouse. So we can orbit our view. To move in the various directions, we hold down the right button and move with the W key to move forward, S to go back, A to go left, D to go right. Like in the most famous first-person games. It doesn't take long to get used to it. And probably, this is much more comfortable than normal 3D software. If we select an object and place the view anywhere else, pressing the F key on the keyboard, we automatically center the same object in the view. Let's do another test with the chair. We look away and we move. I press the F key, and the object is centered again. Another important thing is that you can manage the speed of the camera in two ways. One is by holding the right button and moving the mouse wheel. Turning it towards us, the maximum speed of the camera decreases. If, on the other hand, we rotate it in the opposite direction, the speed of the camera increases. This same setting can be found here, top right. Camera speed and can be controlled via this slider. The two are independent. That is, moving the wheel will not change this value. Let's go back to the classic view, and let's see how we can insert objects into the scene. There are two possibilities for inserting objects into the scene. One is to get them from the place actors. They are objects and functions that are already on Unreal Engine that we can drag on stage. Drag because they must be taken and dragged within the scene. This is an empty actor, i.e. a null and empty object. We can go to the Lights tab and maybe add a light, always dragging it. According to what we just said, we have dragged the light. And now, but only after we put it into the world. We also find it in the World Outliner. The other way is to grab an object from the content browser. We will then see how to import objects into the content browser and how to order it. Let's go to the props. Let's choose this lamp. We drag it. And voila is on stage and also in the World Outliner. It is very simple and very intuitive. So our content browser is our library that we create with the objects we import. And the place actors are all those basic objects and functions that are already in the system. The World Outliner represents the list of objects which was staged in our level. Now that you've seen how the Unreal Engine 5 interface works, in the next lesson we will see how to move in the viewport, assets and all other modules. The interface, the internal logic. Now it's time to tell you about the viewport, asset management and Unreal's internal logic. Let's begin. Right-click in the content browser. This window will open allowing us to create or import any type of object compatible with Unreal or supported by Unreal. The analysis of this small interface allows us to understand which elements Unreal actually works with and get a little more into the logic of the program. It is clear that with new folder we can create a new folder inside the content, and I have to create folders and subfolders to have more order. Import to game is actually nothing more than the function which allows us to import 3D models, animations and textures. It's very simple. You can click on import and select the file from the folder or drag the file into the content browser. Then, in the Create Basic Asset tab, we find Blueprint class. Blueprint classes are, effectively, programming classes. Later in the course, we will address at least a couple of these classes. But they are not essential for a motion design job. It is a purely graphic work. Many of these features relate to game development. But it is also important to know what Unreal is capable of and how he thinks in general. There are tons of item classes. We can't analyze them, but the Unreal Online manual exists. Also, out of curiosity, you can go and comb through and to better understand how it works. Level is important to understand. One of the most important logics of Unreal. Unreal works in levels. Born for the development of video games, it has nevertheless maintained over the years the names of some functions and their own logic. Let's understand what is meant by levels. The levels are what we will commonly call scenes. This is a level. A level has all the objects we insert inside it. If we look in the World Outliner, this level is called Minimal Default and contains all these objects, each with its own parameters that we will analyze later. Let's try to create a new layer. If we create it from the content browser with the same window as before, a new level will be created automatically. By clicking on it, we will be prompted to save the level from which we exit because we cannot open more than one level at a time. So let's make sure we don't save him, and a completely empty layer will open. As you can see, in the World Outliner we have the name of the new level, but it is completely empty. Another way to create a level is File, New Level. In this case, we can choose between 3 different bases. The empty level is what we have seen before. Default has heaven in this plan. Timmy if day allows us to set a day-night cycle. Preset lighting. Let's open a default. He always asks us whether to save the level we are exiting from. Let's say no. We have created a new level. The difference with before is that it hasn't been saved yet. The best thing to do is save current level or Ctrl+S. Choose where to save it. Maybe we can create a new folder here and call it Levels. Inside we can create a level that we will call New Level. Let's now look in the content browser of the Levels folder and the file referring to this level. The file that is generated next to it. It is used for the build of the lights that we will not cover in these lessons. Let's explore the other things that can be created. Not because we will create them, but to understand how Unreal works. On Advanced Assets we see a section dedicated to animations. We can import animations, we can create camera sequences. Blend space, which are the fusion of two animations. And many others very advanced. Also interesting is the paper flipbook, which, as the word itself says, deals with step 1 animations, which then come from images from frames with different FPS. Artificial intelligence is part of the programming. Blendables is part of a particular type of materials, which we will not deal with now. Functions for blueprints. Editor utilities are useful for programming. The foliage system allows you to populate the level with objects. The visual effect with the Niagara system, which is a very advanced particle system. Material and textures are all functions, which are part of the materials. For example, importing media texture. They are videos, sequences of images used as textures. Media is the system for importing various types of media, video and even streaming from external IPs. Miscellaneous is really full of new features. Groom is very interesting, the system of importing hair from other software. Paper 2D is the dedicated part to the realization of the paper flipbooks in the editor. Physics is everything about the physics computation system. And we will see this a little in some lessons later. The management of sounds. User interface does not talk about the system user interface, but it refers to that part of Unreal, which allows you to create graphical interfaces for systems that must be controlled, or simply for video game menus. There are many things, you don't have to be scared, you won't use them all, but it is important to understand how he thinks, and what are the possibilities that Unreal gives us. Another thing introduced in the latest version is the possibility, once registered on the Epic Games site, to have free access to the entire Megascans library. Then, by clicking on Megascans we have the possibility to download the objects generated by photogrammetry or materials. There are so many, it's an incredible resource. But being generated by photogrammetry, they are all photorealistic. It is truly an amazing resource. To import them, just click on each of them. Let's start with an example that helps us understand other functions. Let's insert a cube inside the scene. We see that now this cube is part of the world outliner. That is, everything that is on our level. Now we can use the term level. Not to be confused with layers. Layers are the classic layers that are also used in other software, like on Photoshop, but they only work in editor. These are not things that actually work in the scene. They only serve as an aid to realization. And for the processing of the scene, if you are interested in learning more about them, it is very simple, and just go to the manual, there are very few functions. Now, by clicking on the cube, let's analyze its details tab. The first part refers to the component, because each object, in reality, is a component that has others inside. At the moment you are not interested in it, but it is interesting to know. The cube object is a static mesh, and there is a component inside, which is called static mesh, which allows the software to draw three-dimensional elements. The static mesh may have other functions, but at the moment there is only this. Let's go to what interests us the most. For example, the transform tab, where the coordinates within the world are clearly indicated. Then the location, the rotation and scales. This arrow that is generated is very useful when we manipulate one of these parameters, because we can go back to 0. Obviously, the object is positioned at the 0 of the world, and being the pivot of the cube right in the center, it will sink into this plane which is higher. Let's see the difference between location relative and world. We are now at 0.070. Because, with respect to the center of the world, we have raised the cube by 70. So, its position relative to the center of the world is this. Now let's try to create another cube. We can drag it as before or, holding down the Alt key, and dragging it on an axis, we go to duplicate it. Hence cube 2. Cube 2 has been translated on the y-axis by 150. Let's take the first cube. Holding down the left button, we drag it into the second cube. And we see that the first cube we created became the child of cube 2. What does this mean? That moving the first cube, translating it along any axis, he also carries with him the cube which is his son. The same if we go to rotate it or whatever. If we analyze the location, we see that the location, compared to the world, is this. Let's go get the cube. Let's change its location type to world. And has its own characteristics, so -20, -10 and 70, compared to the center of our stage. But if we set this value to relative, we will see that the values change, because being a child of object 2, these parameters refer to the center of the cube of which it is a child. To be clearer, let's reset all values to 0, and we see that cube 2 has the right world values with respect to it. Cube 1 has 0 values, because it is exactly in the center of cube 2. I hope it is clear. This is very useful during the animation phases. The interface, the internal logic. Each object, each static mesh. It can be animated but not striped. Let's see the other parameters. Mobility. Mobility refers to the behavior of lights and also to the dynamics of the object. Static is an object not affected by dynamic lights, and that it has no possibility to move or interact with other objects. Stationary is something between the static and the movable, but only referring to the behavior of the lights. The movable is a completely dynamic object, both with respect to the calculation of shadows and highlights, both with respect to all functions of dynamics and movement. In our lesson and above all for a purely graphic use, and not to develop video games, they are used mainly, or almost exclusively, movable type objects. Indeed, you set the objects to movable. Then let's go to the static mesh section. Since every Unreal object is an actor, which has components inside, these must be filled. The static mesh component, it means which geometry the software has to draw a cube. We can have the same object, but change the mesh. So it is the same object, but that like static mesh, inside the component has this sphere. It seems a difficult concept. In reality it is very simple, and it's easy to manage. Don't worry now, you will rarely go to change this parameter. Materials is very simple. It is possible from this tab to change the material to our object. Physics allows us to enable the physics of an object. Before giving an example, we need to understand the concept of play and the concept of how to play a scene in Unreal. The Unreal player means the moment when the scene starts, where all programming systems begin. And then we really see what we have achieved. And all the animations are set in motion. It is a concept born from gaming, but it is mastered quite naturally. How do you play a scene? From this button at the top, let's modify the spawn player rust parameter. That is, once we click play, where will our camera be? We do current camera location like this every time we click play. The camera does not move, and let's see what happens. Now let's see what happens to the cube if we enable simulate physics. Nothing, it just has its own physical properties. It will fall away from gravity and will bounce off objects it finds. We then continue with the details. So from here we can configure all the simulation parameters. Enable or disable severity and other parameters. Always with respect to physics. Collisions, we can change the default parameters of an object with respect to its collisions. Assign the physical material to a material that we will see later, and all other functions related to collisions. Lighting, for now we do not care because it is linked only to bake some textures that we will not use in this project. Rendering deals with the on-stage visibility of an object. Everything else is more related than anything else to gaming and programming systems that we will not go to see in these lessons. One important thing is the object management windows. If we go to the content browser, we go to the props, for example, in the starter content. If we double-click on this chair, a new interface will open. It looks quite similar to the normal Unreal interface, but it refers to a single object, and there are all the properties that define it. There are many. You can browse, analyze, and study them from the manual. At the moment we try to simply understand the concepts. For example, this scene, this object, I used a default material, so if we stage it, he will have his material. Let's duplicate it. And we see that, however, as we have seen, it can be changed. But when we import it, it will have its default material if we try to change it. And we save. The material of the object will also change, to which we have not changed the material subsequently. If we go and import another, it will have its default material. This window defines the parameters of the object, which is in the content browser. And saving it will be saved in the object itself. Many things can be defined, like Unreal's basic interface and viewport. Here we can see the objects with the normal rendering system. Unlit, i.e. without the shaders going to work. The wireframe. See only the behavior of the lights and all the rest of the view mode. Similarly to the general viewport. An important thing that we can see in the static mesh management window are collisions, so if we go to show simple collision, let's see what the collision of this object actually is. Because not always the general mesh, the polygons that make up an object, they are actually his collision. Unreal generates this outer mesh with a lower number of polygons, and this is where the objects will collide. You can edit, then delete and create one from this window. Starting from the simple, we can create a spherical shape. One capsule. A box. We can also add them. To create a custom collision system for each object. This will come in handy in our project. Or auto-convex collision. See this window at the bottom right, apply, and the software will try to generate a mesh with very few polygons, but as close as possible to the original mesh. It is also possible to use the same polygons as the geometry. As geometry for collisions. To do this, you need to go to the right panel in the Collision tab. And from Collision Complexity, use Complex Collision as simple. So, as you can see, the collisions are now the same geometries that make up the static mesh. Let's go instead to see the texture management window. Same thing, double-click. A very similar window opens, but it refers to textures. It is very important to manage the channels separately. So, RGB and alpha, we can see the alpha channel, the blue channel, the green channel, and the red channel, see them together. Enabling and disabling the alpha is very useful if we want to see the content of our texture. The parameters we see on the right, they mostly refer to imports. To the compression system, because every time we import a texture, he compresses it in a format more suitable for him. The adjustment tab is quite useful, because in a very simple way, we can vary the brightness, the curves, the saturation, and also minimum and maximum values of alpha directly here. So once saved, the texture will save all those parameters. Definitely. And therefore, when we import it or use it in a material, it will keep the parameters that we have set. An important thing, which perhaps does not really concern the internal logic or the interface, is the snap system. The snap system is essential when assembling a scene. Here we introduce it and make a very brief overview about this function. Snaps are managed here, top right. They can be enabled on surface snapping, or they are disabled. The first snapping we see and which is set by default is this. snap to the grid. Let's disable that plan. Let's go see that there is a grid. And the object will move according to the grid. We can create a snap side based on the size of the grid. That we do 10 and 10. And it means that it will move to one of these, which is 1/10 of a grid cell. We are going to disable it. And we see that we can move the cube and it won't snap to the grid. Let's open another cube for convenience and understanding. Another important snap is that of rotations. We can decide to take a snap every 10 degrees. So when we go to rotate the cube, it will rotate 10 by 10. We can decide to enable or disable it to have a custom rotation. Another important thing, for example, is this icon that we see, which deals with the location of the gizmo, that is, this interface that appears each time we select an object to rotate and move it. If the icon has this symbol of a circle of a world, we will have our gizmo oriented with respect to the world axis, so the x-axis will go up, the y-axis to the right and the x-axis according to where it is oriented, but with respect to the world, if instead we click and exchange this value. On a gizmo with relative coordinates, we will have these handles oriented according to the orientation of the object. So we will actually see what the rotation of the object is. Let's go reset everything. A very important snap is the surface snap, which allows us to snap to surfaces. Surfaces snap between the center of the object and the surface of the neighboring object. You can see by experimenting that it actually doesn't seem to work. It does not snap to any surface. The only way to do this is to move the object, dragging it from that ball that you see inside the gizmo. Then I drag. Now the object will automatically position itself on the surface of the neighboring object. To better understand it, let's stage a sphere. We select our cube, we move it by holding down the left button and dragging the sphere inside, and we see that our cube will position itself always on the surface of the sphere. Familiarize yourself with the Unreal interface. Have fun creating your own custom setup. And if you have any doubts, don't worry. You can write to me in the forum, and I will gladly answer you. In the next lesson, we will talk about the materials and the theory of physically based rendering. Physically based rendering. In this lesson we will start with the PBR theory, to then see how Unreal Engine 5 handles these materials, thanks to the internal material editor. Let's begin. With the right button of the content browser, we create a new material. Let's call it M-Master. Then we will understand why. Double-click on the material to open the material editor. The material editor works in nodes. What does it mean? It means that when we add a new resource, maybe a texture, we will add a new node. And the nodes can be connected to each other. Nodes connect with the left mouse button, dragging it, and delete them by holding down the Alt key and click. Let's see what an Unreal material is made of. Unreal works with a system called PBR, physically based material. Physically based material tries to reproduce a material according to the laws of physics. The materials are divided into electrical and dielectrics. Dielectric materials are wood, plastic, everything that is not metal. Let's go and see node by node, and, in the meantime, let's try to understand the PBR theory. First, we need a base color. The base color is what defines the color of a material, without taking into account reflections, specularity and other things. There are two physically based material workflows: metal roughness and specular glossiness. Unreal uses metal roughness, which has as its main maps the base color we have just mentioned and the roughness. Roughness defines the roughness of a material, hence the reflection. Where it is white it will be wrinkled, therefore not reflective. Where it is black it will be smooth and therefore more reflective. The metallic map will define where a material is electrical and dielectric. In this example of a rusty metal, we will have the part of rust which is a dielectric material. Therefore it does not reflect and it is not metal, while everything else remains metallic. In fact, the metal map defines the completely black dielectric part. The white part, metal material. These three maps together, alone, define a material very well. Then I recommend the Substance PBR guide. Find a link that I leave you below in the lesson sheet. Divide it into two parts. The first very theoretical and the second much more practical on creating maps for the definition of a PBR material. Now let's see how PBR maps are used and how they are managed on Unreal. One thing. Leaving the mouse over the various nodes, Unreal will try to give us a description of them. Let's connect the node to the base material. Now the preview on the left has been updated. It is colored according to this map and left the other default settings. Let's see the preview window. There are several settings. The most interesting is this, that is to define the model on which we want the preview. So a cylinder, a sphere, a plan. Now we don't see it because wedged in this other plane, it's a cube, and this mesh preview. How does it work? We can put any mesh we want. However, we must first do this, go to the content browser. Select a mesh, in this case I select the cone. Return to the master material. And click. Now the preview mesh has become the mesh we have chosen. But let's go back to the sphere, which is very convenient as a preview. We have defined the color. Now let's go to define the roughness, that is, where this material is most reflective. Let's go insert as roughness map. We drag it into the material editor. Let's drag it into roughness. If we now go and see the clearest and most reflective part, the rusty part does not reflect. Let's do an experiment. We insert the roughness map instead of the color one. So we can see it, and we can see that where the roughness map is black is more reflective and where white less. There is also another way to preview a node. And right-click on the Start Previewing node. And it just shows us the result of that knot. To stop it we have to stop. Now let's insert the metallic map. And it is immediately clear from the preview how the software interprets the parts where the map is clear as metal parts and the darker ones as non-metallic. It is good to define that numerically in an 8-bit image. That goes from black to white. The completely white part is defined as 1, while the completely black one is 0. So the value of 0 of metallic defines an electrical material, while the 0 point of the roughness defines when the material is smooth, therefore more reflective. To deepen these topics, always refer to the guide that I mentioned earlier, which clarifies a lot the slightly more technical side of the PBR material. We have established the base color, where our material is electrical and where dielectric. The roughness. Now let's talk about normal maps. Normal maps work like in any other 3D software. It's those two-dimensional maps which give the illusion of micro details on a mesh. without necessarily increasing the number of polygons. It is a two-dimensional map that maps to the UVs and gives this illusion of micro details. It works exactly in all other software. Perhaps the only difference could be that working with DirectX, the green channel is inverted. Let's see how it works. We choose a texture in the material editor. We plug it in and go see that immediately. The normal map does its duty. Let's say we can already say that we have made the first material, but Unreal's material editor offers us tons of features. We skip the specular. The specularity factor of a material, it is defined with a value from 0 to 1. If we do right-click, we do promote to parameter. He creates this knot that is simply a knot, where we can enter a numeric value. By default it is 1, unless we vary it, as here, with 0.5. Anisotropy is a type of specularity of some specific electrical materials. Emissive color is the color that emits a certain type of material. Let's go experiment. You see? It is as if it emits light and emits it of this color. We will then deepen this in another chapter. But let's forget the tangent, the world position offset, ambient occlusion and pixel depth offset. These are advanced parameters that we will not address in this course and which refer to other material properties. Let's say we want to change the reflection of this material. What do? Right key. Lerp. Or L on the keyboard. And let's open this node, which is linear interpolation. Giving an A value in the alpha channel, in this case we are talking about roughness, hence this knot. Another important thing. Double-click on the material. The editor opens, let's call it texture editor, where we can do a texture setup. And also check the various channels. Obviously we work in RGB, we display the channels separately. So we turn them off. We look at the red channel. We look at the green channel, the blue channel. Roughness has all three channels alike, because we are only interested in this value. But when we put them into linear interpolation's alpha channel, we only have to take one of these channels, which for us is the same because they are the same. So we broke the knot and rejoined the linear interpolation node with roughness. We click on the node and go to the left, where there is the details panel and we see the values of this node. Let's try to shut down alpha with Alt. We click on the node. He gives a constant value of 0.5. When we connect a value to the node, this value turns gray because the input of this node, it takes it from the red value of this texture. So we have the value of 0 on A and B1. What does it mean? As we said before, the value of an RGB texture ranges from completely white, 1, completely black, 0. Linear interpolation defines these two maximum values. So constant A is completely black, starting from 0. The constant B completely white, 1, but I can change these values. Then tighten this range and modify it. Let's see what happens if we change these parameters. By setting a minimum value of 1, it will become all white. You see, everything becomes completely opaque. Let's go see the preview of this node. We stop, then all white for the roughness. It means wrinkled, so it doesn't reflect. Let's do the opposite, 0 and 0. It will all become reflective. What allows us to do this? It allows us to adjust this parameter. Normally, when we use a roughness map, it is good to create a limit to the minimum value, usually it is 0.3. In addition to having taken on a more realistic image, the type of material in the part where it was more reflective has really changed. By acting on this parameter, we can customize the behavior of the reflection. Let's see what the parameters of the material are. Click on Master Material. And let's see the Details panel on the left. Physical material. For now we are not interested, we will deal with it later. Material defines the type of material, what we need to use it for, normally surface. The decal are another thing that we will see later. Light function are materials that are applied to lights to create effects on the light. Volumes are for mists and things like that. Post-processing is a particular material, which is for color grading or stuff like that. And user interface is used when they create interfaces on Unreal. For games or applications, as a rule, we use surface. Blend mode is the type of material we are going to create. The first is the default one. Masked is a kind of material, you see, opacity mask node is turned on. Basically, it defines the opacity of a material. It works a bit like metal's roughness and map, black and white. Where it is black it is opaque, where it is white it is transparent. In fact, if we use the metal map on the opacity map, do you see that it has become transparent? But it does it in a clear way, it does not allow for nuances. Let's see translucent. Translucent is like mask, but it has many more parameters and allows a gradual type mask. That is, we can put a gradient opacity. Translucent has many other parameters that we will not see in the course, but if you are interested, you can also learn more with the manual. Let's go back to our normal material. There are many other parameters. Shading models are some presets that Unreal gives us to help us, like the subsurface, hair, cloth, or unlit, which is a system. So the material is not affected by lights and reflections. Two-sided means that the material is visible both on the side of the normals of a polygon and on the other side. And then, gradually, many parameters, which unfortunately we cannot rattle off all in this course. What we have said already allows us to create materials. Why did we initially call this material master material? Because we can create a material. Create our nodes so that we can customize it and, for example, linear interpolation could be a parameter which allows us to calibrate our material in the scene. I'll show you how. Meanwhile, let's save this material. Let's go to the color node. Right key. Convert to parameter. We call it color. Let's click again and go to see in detail. The parameter is called color, the group we will call texture. We leave the rest unchanged. We do the same thing for the remaining nodes. We convert to parameter. We call this metallic. Once we have created one, if we see on this curtain, we find the group we created earlier. We don't have to rewrite it, and we don't have to remember the groups we've created. Same thing, roughness. Texture group. Normal. Texture group. Let's see what we've done. Let's go to the content browser. Let's see the material we have saved. Let's right-click, and now we have the ability to do create material instance. What is the material instance? It is a child material that takes properties from the master material that we have created, and let's go and open it. It exposes us the parameters that we have defined. So we said the four maps are parameters that we can change. Therefore, at any time we can take the color map and change it. And what is the created group? It is none other than the texture group. In the graphical interface it will be a group, which allows us to find our parameters and to be able to use them. Let's reopen the material editor. Specular we had created it as a parameter, but we hadn't given him any groups. We also do this other very convenient thing for the creation of a material, and then, later on, we will create our master material with the parameters that interest us. Let's right-click on property A and do promote to parameter. Let's call it R-min, minimal roughness. Let's create a roughness group. We do the same thing on B. But we will call it R-max. We will put him in the same group. We save. Now let's assign this object. We have several ways to assign a material to an object: by dragging it, or by selecting the object from the world outliner. Go into Details. And under the Materials tab we can choose which material to assign. We can either drag it here or with this search. Indeed, let's do this. Let's rename it. Let's call it mrust. Now let's click on the object. We double-click on the material. Let's undock this window. Now from the viewport directly from the render, we can set this value according to how we like it. Do you see how it changes? Obviously, both values must go on a scale of 0 to 1. If I give the minimum reflection value 0, it will reflect at 100%. If I give a value of 1, he will stop thinking. We have created our first instance material with our customization. If you want to learn more about the PBR theory, remember to consult the guide. I leave you the link in the additional resources. Don't worry, this lesson was pure theory, but it will all be much clearer when we make our first and true material. In the next lesson, let's see how the new modeling module works. Modeling Tool Module. With the arrival of Unreal Engine 5, we have an internal module for modeling objects. This allows us, for the first time, to manage an entire project from start to finish with the only use of Unreal. My advice now is to experiment and have fun. Let's begin. By default, the modeling plugin is not enabled. We have to go to Settings, Plugins. We just need to type modeling in the search field and enable it. I have already done it, but you will have to do it. You will be prompted to restart the software. After that, this icon will appear. It will allow us to enter the editing mode by clicking here, or with the key combination Shift plus F7. In this lesson, we will look at just some of these tools. But then I invite you to have fun and experience them one at a time. They are simple to understand and quite explanatory. In the Shape tab we have all the tools that allow us to create primitive objects, like a cube, a sphere, a cylinder, the cone, and so on. We can also create flat objects like this. This is a plane with rounded corners, which we can then extrude and use as a basis for modeling other objects. We select the cube. First, this cube will snap to the mouse. And on the left we will have all the options to create this cube. Let's start with the first polygroup. On Unreal, a polygroup is a set of polygons. We can make one polygroup per face. Only one polygroup, or one for each quad, that is, for each square polygon. It will be used to assign different materials to each group of polygons, or for editing. Then we have the dimensions that determine the size of the cube. The subdivisions will allow us to divide the various objects into multiple polygons. A very interesting thing is this positioning. If it suits us to change the object to understand better, let's create a sphere. We place it here. And then we create a box. See what happens if we're on the positioning on scene. Our cube will be positioned with a snap on the base, based on the geometries around it. We can make a cube here. Another one here. The other options are ground plane. That is, it remains at 0 on the x-axis. Very convenient for placing objects on stage from which to start. I will not be here to say all the options with which to create the items, because they are really self-explanatory and very simple to understand. More interesting, however, the polyextrude, which allows us to draw a spline on this plane. I position myself on top to let you see it better. I can draw a spline on this plane and then extrude it. Let's see some features of this tool, which are quite interesting. Polygon mode, that is, from which form we start. Before we did freehand, we drew point by point. Now I have selected circle, and it creates a circle which I can then extrude. A rectangular rectangle with rounded edges. With polyextrude we can create the shape we want, extrude it, and use it as a starting point for modeling. I deactivate this floor, because it prevents me from seeing what I am doing. Path extrude, on the other hand, is more or less the same tool, but it does this thing. As soon as I close this spline, it gives me the ability to create thickness and extrude it along an axis. This gives me the ability to create more complex shapes. Path revolve is very interesting. It is always based on splines and allows us to extrude with one revolution. Drawing half the spline and leaving the first 2 points at 0, what it will do is just what the name says. We'll extrude in one revolution along an axis. Let's try another form. Let's create a cube and leave per face in the polygroup mode settings. We click on the complete button and we have made our cube. Let's go to polymodel. As you see, we can select for polygroup. As we said before, to create a polygroup for each face, it will make us select one face at a time. So, let's select and see what we can do. We can translate this polygroup along any axis. We can climb it. We can rotate it. The gizmo section is interesting. It allows us to set up this gizmo, that is, the one with which we then go to interact. Allows you to snap to the world grid. And maybe block the rotation. An interesting thing is that we can select a polygroup in the Face Edits tab and we can extrude it. We can create an offset. An internal extrusion he calls inset. We can merge with another polygroup. We can erase it, we can cut the face. In short, we can edit it, but we are always talking about polyedit. Polydeform allows us to deform by polygroup. It's something I don't see a lot of use for. If you want to experiment, go ahead, but I hardly find a use. It allows these types of deformations on the mesh. But I really don't know what use to make of it at the moment. Very interesting is Adjainsert. It allows you to create edges By defining 2 points, he will cut the polygons. LoopInsert, very interesting, creates an edge loop. Boolean is also very interesting. Classic Boolean operation between 2 objects. Let's take the sphere. We intersect it with the cube. We select them both, click on Boolean. And we can say to subtract object A from object B. The other way around. To leave only the part of the intersection between the 2 or to join them. TriModel deals with modeling, editing, based on polygons. Then select polygons and edit polygons. It has more or less the same functions as Polymodel, but it acts singularly on polygons. I can extrude a polygon, remove a polygon or merge 2 polygons. A very interesting object that we will often use for the project is the pin cut. Basically, a plane that cuts the object. Very interesting. We can act on this level, modify it to make it cut the object differently. Mirror that mirrors, a kind of symmetry of objects. Let's quickly move on to deform. A fairly quick overview. Vertex Sculpt allows you to paint as a sculpting software would. So I can use a smooth filter. Inflate. In short, you can have fun with classic tools for sculpture. But don't expect Blender or ZBrush. However, it works and can be useful at times. Dynamic Sculpt is another type of sculpture. Smooth, the word itself says it is an interaction of smooth. Then it softens the model. Offset is very interesting. It just creates an offset of the geometry. A deformer, which has nothing to do with sculpting, but it is certainly very useful as warp. We can use it with operation type bend. It is just a trainer who takes care of folding a bend, as some other software would call it. Flare and squish is a kind of squash and stretch. And twist. I took off Show Original Mesh because it bothered us. He is an excellent informant who will often come in handy. The inevitable lattice that creates a grid around the mesh. We can choose how many subdivisions. Then we go to select the points that interest us. This cage will deform the object inside. We will also see this later during processing because it is very useful. We see this object on all views. In the transform section, the thing that is certainly more useful to us is pivot. Let's go and see it calmly. We note that the pivot, the center of rotation, it's at the bottom because we set it up during creation. We select pivot. See how simple it is to move the origin point, center, at the center of geometry. Bottom, down where it was before, top, left and right. World origin sets it at the center of the world, E at 0 and 0 with respect to the scene. This will be very useful to us. Meshups. We're not going to test it. It just serves to simplify the geometry, to automatically reduce the number of polygons. Remesh is used to increase the number of polygons, in case more density is needed to increase the details. Vox operator transforms geometries into voxels and then transforms them back into geometries. It won't be useful to us in our course. I'll show it to you just out of curiosity. See how he transformed the geometries. With voxel computation, he merged them and created a new geometry. Other very interesting tools are what you need to manage the normals, the smoothing groups, and the material editor. We will not see it now, we will see it during the course, but it is really very important. It is used to assign material slots to different polygroups. Unwrap's automatic system is also very nice. It works very well, and we will use it too during the course. There is the possibility of making an unwrap with the various classic projections: cubic, spherical, and cylindrical. Each time you create a new item, Unreal will automatically create a folder in the content browser called Generated. There will be a subfolder inside with the username you registered with Unreal. What happened? The system automatically saves an asset, the geometry, which corresponds to the one that was just created, and with any substantial modification, either the geometry is updated or another one is created. This is important because, in the end, after making all the changes, it is a good idea to rename this object and move it to the right folder, so that you can call it up easily every time. It will happen that this folder will fill up with temporary objects that can be safely thrown away. Now that you know the tools that allow you to model on Unreal, have fun and experiment. You will see that it will be easier for you to realize your final project. In the next lesson, we will talk about the use of lights on Unreal and the different types of light to use. Lighting basics. In this lesson, we will look at what types of light makes Unreal available to us, analyzing them in detail. It is indeed important to know the types of light available to better illuminate the scene. Let's begin. The types of light available can be found in the Place Actor tab, under Lights, or Create Lights. Let's go see the first type of light, directional lights. Directional light is very simple, an infinite light like the sun. It affects the whole scene, and its position in the world does not change the illumination. Let's look at it better. Trying to move it, we won't have any changes. Imagine it as the sun, a very, very distant light. But its angle determines the origin. For now we turn it off. The easiest way to turn off the lights is to go to the Detail panel and click on Effects World. Let's go and see the point light. It must be conceived as a light bulb. It has an origin in a sphere of influence where it then decays. Spotlight is exactly a spotlight, which affects the inside of its cone. Rectlight stands for rectangular light and is a light that originates from a rectangle. Imagine it as a window and affects only in the X direction. As you can see, if I rotate it 180 degrees, it will only illuminate this side of the scene. It is very useful and we will see it later. Let's go see the skylight. It would seem to do nothing, because the skylight has the function of capturing what is around the scene and use it to reflect or emit light. In this case, there is nothing in the scene, but let's see how it works in this case. Source type. We tell him to specify a cube-em-up, we go to select it. And let's see what happened. Let's imagine the skylight as a dome, like a huge sphere around our scene. If we select an HDR, this will try to coherently illuminate the scene based on the information, like a global illumination, but very rough. What is contained in the cube-em-up will also affect the reflection. Then it will be reflected in the reflections. The skylight should be investigated and explained a little more thoroughly. We won't do it in these lessons, it does not specifically concern the project we will carry out. So for now, we let this little explanation suffice. Let's disable it and see how the lights work. We note that, like all objects staged on Unreal, in the Details tab we have the Transform section with location, rotation and scale. But here is this new option, which is mobility. The first two, static and stationary, relate to video game development. They make the lights non-dynamic, in the sense that with the rendering procedure, these lights are then, in jargon, cooked, and their influence on various objects is inscribed in other textures and printed. So, if we then go to move this light or an object, the lighting will not change. However, this is not the case here, we will then see, thanks to the Lumen Global Illumination System, as we have to use movable lights. Then, under the Light section, we can change the intensity of the light, change the color in which the light is emitted. Attenuation radius is very important. It is the area of influence of the light. If I decrease this radius, you see that outside that sphere the light has no effect. Let's see these three options: source radius, soft source radius and source length. What is the light source? What is meant? Imagine it just like a light bulb. It is no coincidence that I have inserted this mirror wall to show us what is meant by radius. The source radius is just the bulb of a light bulb. I can increase its radius, make its outline softer, or stretch it. We can use the color temperature. By default it is 6500 Kelvin. We can make cooler lights or warmer lights. We can tell a light not to cast shadows. This is useful in case we are using some light just to paint the scene, or to correct the scene. Let's turn off this light for a moment and go to Spotlight. The Spotlight has the same options as a point light. Plus it can define the influence of the external cone of the spotlight. Otherwise, it is identical in options to the other lights. The rectangular light, as we said, it is also very interesting because it gives a very realistic result. As options, it differs for the barn door angle and the barn door length. Actually, it determines the angle of that outer frame. Just imagine this geometry as the light source. Therefore, by changing this angle, we also change the effect of the light. The use of these three types of light varies according to the needs of the moment. It takes some practice. And we will see later how to best use a type of light, and when to use one type of light over another. Now that you've seen how to have fun with lights on Unreal, let's move on to the next lesson where I will tell you how to use lumens and global illumination in real time with this new module. The new Lumen lighting engine. In this lesson, I want to tell you about the global illumination theory, and then how Lumen, the new internal rendering system, brings global illumination in real time for the first time on Unreal Engine. Follow this lesson carefully, because this is where the key to the revolution lies: real-time graphics. Let's begin. Unreal Engine 5 introduced the new rendering system, called Lumen. Once the software is started, however, we should enable it. To do this, let's go to the Settings section. Project Settings. Let's go to the Engine section. Rendering. Let's scroll down to find the Global Illumination tab. As you can see, I have already activated it. On first launch, you will need to select Lumen within the Global Illumination tab, and also in the Reflection tab, in order to let the Lumen manage the global illumination, but also the reflections. Capture resolution is fine at 128 for now, and also for our project. We enable detail tracing and virtual shadow map, which is the new shadow calculation system. It is possible to enable the ray tracing hardware, but at the moment, Epic does not recommend it at this stage of development. And in any case, I was able to test the efficiency of Lumen without ray tracing hardware, but with only the software system. From this moment we can use Lumen as a lighting system. Let's set up a post-processing volume in the scene. And we set the volume to infinite extent or unbound to make it affect the whole scene, and not only within its own volume. Now you can place the volume anywhere in the scene, but it will affect the whole scene. This scene contains a cube open on one face. And a spotlight. As you can see, the light only has an effect inside the cone, and it does not propagate in any way. Let's go put a cube. As you can see, the cube is illuminated only where, actually, is cut from the cone. In reality, this is not the case. In reality, the light bounces. And this is the difference between direct lighting systems and those with so-called indirect illumination. This graph makes it clear at a glance, the difference between the two lighting systems. With direct illumination, the light emits rays, which simply bounce once on the hit object. Indirect lighting is the one that takes into account the bounces of light, because light actually bounces off the surface and spreads in all directions. This causes the light to spread around a room, and that also takes into account the color of the object on which it bounced. Please note that the bounces to be calculated will not be just one, as you can see here. This example takes into account a system of a bounce or rebound of light. 2 bounces. As you can see, the situation becomes very complicated for the calculation. And 3 bounces, but many more are used in rendering. Let's see in practice what this difference is. Once the post-processing volume is activated, in the global illumination section, we are going to enable Lumen. We can instantly see what has changed. Just what we just said. Direct light does not bounce, so it only takes effect where the light beam falls. While global illumination or indirect light, consider ribbons, and how light propagates between objects. Now we're going to rehabilitate him, and we immediately see how the light spreads throughout the room and bounces, creating a diffused light. Always remember to set the final gather quality in the same tab at 2. And, again, to enable reflection under lumen. And put 2 also under the quality of the reflection. We also do another test. In this scene there are 2 spheres to which I have assigned this material. Let's see what this material contains. Simply, a color in the base color. And the same color in the emissive color. Let's go enable it and see what happens. I had hidden them before, so we make them visible. And, with no light on stage, because the spotlight no longer has an effect on stage, the emissive material alone creates a propagation of light. This can only be done with global illumination. There is little more to say about Unreal's global illumination. Some parameters will be addressed only in the rendering phase, and we will see them, in fact, in the final stages of the project. Let's say this is the biggest evolution of this version of Unreal, and the fact that it does it in real time is something new, which we will also use in our final project. See how easy it is to get amazing results with very few steps. In the next lesson, we will see the blueprint system, which is none other than Unreal's visual scripting system. Visual scripting blueprint. In this lesson, I will tell you about the blueprint system, which is none other than Unreal's internal programming system, completely visual. I shouldn't write a single line of code. Let's begin. The blueprint system is a visual node system for programming, which also allowed me, who am not a programmer, and I know hardly any programming concepts, to use it, at first for very simple things, and then, gradually, for more advanced animation functions. Let's go to the blueprints section. We see that we have open level blueprints. Let's click and see what happens. This is the blueprint panel. The level blueprint, the one we have entered now. It concerns precisely the programming of the level we are addressing, where we are working. Every time we play the scene, the rules written in the level blueprint will affect the whole scene. But we could create classes. Programming classes are objects, which have internal programming and are replicable. I can have an object to which I assign a behavior, and then replicate it in the scene and duplicate it, and any child object of that blueprint class must comply with these rules and those of the level blueprint. Let's see how a blueprint class is created. Right button in the content browser. Blueprint class. As you can see, there are an infinity of classes, because Unreal really allows every kind of interaction and has a lot of utilities for programming. For our project, we will only need to know what an actor is. An actor, the word itself says, is a stage actor who can have properties. Let's go create one. Double-click. Lector may have components inside. It can be the geometries, so our actor can be a character. It can have sounds, and it can have particle or a skeleton mesh, which is none other than his rig. It can have so many other things. Let's create a very simple actor with a sphere. We save. We are going to insert it into the scene, and what we see in the viewport is the mesh component. That is the geometry that makes up this blueprint. Let's go inside again. We are now in the Viewport tab. There are 2 other tabs for the classes: Event Graph and Construction Script. We will focus on the Event Graph though. In the Event Graph there is precisely the programming part, the behavior of the class. So here you program, here you create the rules of this class, and every time we put one on stage, this class will keep in mind some internal programming. It is a basic, elementary concept for those who program. For us who do motion design, it is perhaps something new that we have never used. We will use it to create the initial animation of our scene, and you will see that everything will be clearer. Let's take a small programming example with blueprints. Let's go to the level blueprint. Two nodes immediately arise. These are two event type nodes. Event begin play, as the word itself says, is an event, which is triggered when the scene is played. Just as you click the play button. Event tick is an event that is triggered at every tick of the scene. It means at every frame. If we go to 25 frames per second, we will have a tick for each frame. Let's try to see how it works, and let's see how it works in Blueprint. The system of nodes, at the interface level, is the same as that of the material editor, so if we want to create a new node, we drag this node. And we can search in the list of available names. Or we right-click in the grid and look for a node. We want to trigger an event as soon as the scene starts, then left-click. And look for the print node. The print string node makes a text appear when the event is triggered, event begin play. The event will greet us with hello world and will last 3 seconds. And we do it purple. We compile, because in addition to saving, we must compile, as if we had really programmed the classic way, and we save. Let's go back to our scene, let's play it. Here is the text hello world. After 3 seconds it disappears, because the triggering event was the very start of the scene. Let's try to see what happens if the triggering event is event tick. Therefore at each system tick, at each frame, as you see, the system keeps giving us this print string. I have prepared a scene with a light. Let's try to control a light with the blueprint system. Let's start with what triggers the event of light. Let's say that by entering the room inside this cube, we want the light to come on. How can we do? Among the various volumes that Unreal makes available to us, we have the trigger volume. I have already entered the scene, as you can see, but we can review the operation. The trigger volume has few parameters, other than the size. We bring it to the stage and climb it, but I've already done it, as you see, the same size as this cube. Let's go and select the light on stage. Let's go back to our blueprint, right-click. Create a reference to point light. We now have a node that refers to point light itself. Let's drag this node and look for set intensity of the light component. Automatically, the system will create this conversion node. But at the moment we don't care. What's going to happen? This node allows us to control the intensity of the light. Let's go instead to create the rule that says that the intensity of the light must be set to 100. Only when the chamber enters this volume. Then we select trigger volume. Let's go back to our blueprint. Right-click and we already see that Unreal helps us with add event for trigger collision and select add on actor begin overlap. Bon means nothing more than when the actor, in this case we enter the cube, we intersect with the cube. When this is true, it causes the next set light command to run, which takes the settings and other nodes we have established. So when we cross the volume, this node will be told to set the light intensity to 100. Let's see if it works. We compile, we save, we go back to our scene. The light intensity value is normally set to 0 by the scene. Let's play the scene. Moving inside the cube. And we see that the light comes on. It worked. Now let's say we want the light to go out. Once we get out of the volume. Always selecting the volume. Let's go back to the blueprint. Right key. Also in the collision section, add on actor end overlap. That is, when the intersection ends. When the actor is no longer inside the trigger volume, we can copy and paste this node. Set the value 0. Set the target always using this node. But the event that will trigger this node will be this. What I expect to see now is that, coming out of the volume, the light goes out. Let's go test. The light went on. On leaving, the light goes out. It was very easy to program this thing. We can comment on our programming section. We select the nodes, we press C, and we call it overlap loose. Let's say that at this point we want to create a condition. We want to create a kind of switch. Let's say that if we don't go through this geometry first, if we don't go in here first, the lighting system cannot be active. For those who program this is, let's say, elementary. But let's see how to deal with it to use, for the first time, a variable. In programming, any programmer would use an if function. In fact, searching for if among the nodes available in the blueprints, we have branch, which is a condition node. If this condition is true, the exec node will be true. If this condition is false, the false node will be the exec. So, to control the intensity of the light, we must first have gone through here. I have already set a trigger volume here. But let's define the characteristics. Trigger volume. Same thing as before, right-click, add on actor begin overlap. What event should we unleash? What do we need to change as we step into this trigger volume? We need to set the value of this condition, which, at the moment, is here in the node, but we need to create a variable. We call this variable switch. Let's leave it as a type of Boolean variable. But Unreal gives us all kinds of existing variables, and even beyond. Let's compile and set its default value to false. Let's drag it into the blueprint. As you see, we can call it with get. Or create a node where we set the value of the variable with set. On the one hand, we hear the value of the variable based on the event. On the other hand, with get, we go to retrieve the value, which we will need just to determine the condition and the branch node above. So when we go through that volume, the set variable becomes true. In this way, branch's condition is true and we turn on the light. This node must now be connected to branch. According to what I expect is that if we go into this volume, before passing here, the light shouldn't go on. Once inside this volume, we have the ability to turn this light on and off. Let's help with debugging. Let's say when the condition is active, we activate a signal on the screen that indicates it to us. Okay, let's save, compile and go try the scene. We enter the volume and nothing happens. Now let's get into this volume first. And it works, so the switch is on. Now we go into the other volume and the light goes on and off. Don't worry if the blueprints seem tough to you at first. By mastering them, however, you will find them very funny. Do not forget that also the example you saw in this lesson, you can find it in the additional resources. We have come to the end of these units. Now you know the Unreal interface, the various modules, and all the tools at your disposal. In the next unit, we will see how to use them to create the final project. Moodboard and storyboard. In this lesson, I want to show you the moodboard and storyboard that I created for our final project. When I have to carry out a project, I always start with a goal. When Domestika called me to carry out this course, I thought of it as a client and created their logo animation. I think of my projects, even the very short ones, as a story. In fact, in this case I made both a moodboard and a storyboard. Let's start by looking at the moodboard. The idea is to create a room for someone who takes the Domestika course. And I imagine it colorful. And someone who wants to make art. The moodboard defines the colors, defines the scene and the framing, and defines the flavor of our whole project. The moodboard, in this case, is the last scene of the final project, a large one in which we see the whole room and all the objects. With the moodboard in hand, you may already know which objects to start modeling. We will start with the vase. But you can start with any other object. From the cube from the monitor.